you that you can do the cheat sheet up to 3 pieces of A4 size, total of 6 pages. Cannot be print or photocopy. Alright. So today, basically the main thing is basically just go through all the project. Alright. So I'm gonna randomly choose one of the project. Alright. And when your friend make a presentation, I expect each group ask some question, at least like 1 or 2 questions. Alright. The total question asked of each group will affect the grade also. Alright. So please pay attention on what your friend make presentation. Alright. I'll randomly choose one of group. Each group have about up to 20 minutes, right? So the first group is about factor analysis. Okay.
So, hi everyone, and today we will present to you about factor analysis. And our agenda here today is we are going to the objective of factor analysis, the benefit, limitation, keywords to know about this, and step in factor analysis. And then lastly, we will go to the sample case that we did, which is the Kasi bubble sheet. So, first, the objective is to reduce the data to a smaller set of summary by grouping of variables that are highly related, both positive and negative way. So, in relativity, we have multiple variables and we just want to group them together and to determine the number of factors that have significant influence on the group. And lastly, to check the relationship of each factor and the relationship of each variable. And the benefit of factor analysis is first, is reduce the number of variables. We can have hundreds of variables and we want to group them into similar things, and the remaining, the group would be the factor and remaining of the original information as we need it. And by relying on the combination into one factor that considered as a new variable, and then we create a factor score, which is a variable of number that represent parallel sample. And then second benefit is to study the relationship of the structure of each factor. And lastly, multi-collinearity solution of regression analysis. The limitation of this is that the collect data should be multivariate data, and also that means that the observed sample can be determined by many variable factors. For example, human can be determined by the weight, the height, the heart rate, the blood pressure. Also, the data should be quantitative variable, and variable data should have high correlation, and relationship between factor and variable is only in linear form. Sample should be large enough for at least 3 observations per variable and more than 5 to 10 times. And convergence analysis will be used for data with the same unit. And if the data have different units, it will be correlation analysis. Forward to know, we show here is data metric and statistic method used in factor analysis. And for data metric is given P is the number of the variable, and so it's just crossing the as a metric, and then we count each as a variable. And for statistic method, both are used to see relationship between variables, but like mentioned in earlier slides, one is for the same unit and one is for the different unit. Also, for factor analysis, So for factor analysis, it is used when the such as the number are continuous for both relationships such as weight and height. They are continuous, so we would use factor analysis. If the number are not for the all the factor are not continuous, we would use other method shown here. And next word to know is common factor. So for common factor is the variable in the same in like multiple variable grouping into one factor. Such as here shown here, maybe factor variable 1, 2, and 5 can be grouped into factor 1. Eigenvalue is measure of how much the variance of the observed variable of factor is explained. Any factor with an eigenvalue of more than 1 explain more variance than a single observed value. So to do conclude how much factor we should have. For example, in this table here, as you can see, so here cutting in the point here, so if we have 2 factors in this component, meaning that because if you see the total here, this is more than 1, but if go like 3, 4 factor, it will be less than 1 already. So we need 2 factors only for this case. And for another word to know is communality. Communality is relationship of one variable with another among all variables, which is ranging between 0 to 1. The correlation of all other items, and the higher the better. Screen plot is plotting of eigenvalue to see if it's more than 1. So the same thing here. So you see this is the point 1, point 2. So for this set of data is 2 factors. And next is factor loading. Factor loading are variables that represent the strength of the relationship between the unobserved factor and the observed variable. So for example here in the group, let's see self-esteem and self-efficacy. This is in factor 2 is high, meaning that these two are related, but then the sign are opposite, meaning that is related in a different way. Meaning if one is high, one will be low. And also in the same manner, optimism and determination, both are high, more than 0.4, so both are high, and then it's in the same side, both are positive. So meaning if one increase, the other also increase. Factor score is calculated by substituting actual data of the same variable into linear equation to be used as new variable. So initially, it will just create like a linear for you to calculate the data. And lastly, our example is the Nakasi bubble tea. The reason that we choose to do Nakasi is because we like to drink bubble tea, and it has many stores. The brand is quite popular and delicious. And the questionnaire that we did was that we surveyed the customer satisfaction toward Nakasi, and then we categorize the major factor that influence their satisfaction. And we have multiple questions regarding the marketing mix, such as the product, the price, the place, the promotions.
We are going to introduce the procedure and the result and how to interpret the result. We are going to introduce the following steps. The first one is to determine whether the data is suitable for the factor analysis. And the second one and the third one is about how to extract the factors and how many factors is present. And the fourth one is if the result is hard to explain, so there is some method we can do to make the result easy to read. And the final part is And first, we have to see whether the data is suitable or not. So we can see this KMO statistics first. It's if the value of KMO is lower than 0.5, it means that the data is not suitable for vector analysis. And we can see the correlation matrix and the valid test for the test. It's about because our goal to do vector analysis is to reduce the dimension, which means to reduce the variable we use. And if the variables are all independent with each other, which means all the variables cannot be categorized by some kind of structure. You cannot separate the lower dimension. So we need to do the valid test to see whether the all variables are correlated or not. If we can reject the null hypothesis, which means the data is suitable for the vector analysis.
Yes, so in the case of the Casa bubble T, we also first started with the correlation metrics. So we took our 22 questions, and then we checked whether those questions correlate with one another, so the values that we got. And it was important for us to check whether the values are below 0.8. And in our case, everything was below 0.8, so we could avoid multicollinearity. So this data was indicated for the subsequent analysis. The next step, we did the KMO and the Bartlett's test. So first of all, the KMO measure was above 0.5, so it is suitable to do the vector analysis. And the second step, the p-value of the Bartlett's test was checked. So it was 0.00, which means that we reject the null hypothesis. And this means that some of the data or some of the variables are related. So the collected data from us is suitable for the vector analysis model.
And the second step is to introduce the method to extract the vectors. And there are so many techniques. Like the first one is maximum likelihood method. It's a model-based method. We need to do some normal assumption to do this. But sometimes it's not that good to fit the model. So the PCA, the principal component analysis method, is more common to use with the vector analysis. And if the vector loading is greater than 0.4, we regard this as quite significant for the relation between variables and vectors. So if the loading is lower than 0.4, we will delete the vector. And as we mentioned before, the eigenvalue means that how much it can explain the data. So the higher the eigenvalue means it can explain more variation in the data. And script plot is which is the version of these tables that visualize the table. So we can see that in this case, there are the two components is null because these two components can explain about 98% of the variation.
Yes, and coming back to our case, so we also looked at the total variance explained for the questions that we had. We can see that the first 7 variables, they explain about 80% of the total variation, which you can also see in the script plot. So the first 7 variables had a value of about 1 or higher. So we chose to go with those variables for our further vector analysis.
And the rotation method is for the result is hard to explain. So there are two ways can help us. The first way is orthogonal. The other way is uplooking. Orthogonal means that you will rotate the original vector to make the vector less with no correlation. Yes. So they will do that. Yes. The vectors will be uncorrelated in this method. And in other, it's a method to make the vectors less correlated. And these two can help us to do the further interpretation of the vector analysis. Because if the vectors are highly correlated, we can hardly to explain the pure effect of of the specific vector.
So coming back to our case, the principal vector analysis that we conducted was quite hard to interpret. So most of the vectors were found in component number 1. And so we had to use some rotational method to interpret the factors more. So we used the Varimax rotation, and after conducting this rotation, we can see a more clear distinction between the factors and the components. So the first 4 components, 1 to 4, are able to explain most of our variables. So we decided to go with the first 4 components for the further analysis for the interpretation. And also in this case, you can already see we already discarded all of the loadings below 0.4, so only loadings above 0.4 included in the component vectors. As the vectors below 0.4, as we said below, are not significant for our analysis.
And the final part is to interpret the result. And the result is the way we explain is like it's just the same with the regression analysis. In regression, we do use independent variables to explain dependent variables. And now in this case, in vector analysis, we find a few common factors to explain all the variables we have, which means we can categorize the variable and find their common, find the common things we can explain. Yes.
So if we look back at our variables for a moment, we can see we have factors like the size of bubbles, like the quantity of bubbles, and all of these sorts of questions. And then in the interpretation, like for size of bubbles, taste of bubbles, we can all see there in the component number 1. So our interpretation for this is the product characteristic. And we continued like this for the other questions, and our 4 factors were named after this. So we had the product characteristics, the attractiveness of brand, the quality of service, and the perceived value for money. So at the end of this analysis, we have these 4 factors that include like different questions that we can use for the subsequent analysis. And we can see that these 22 questions that we had basically can be summarized in 4 factors and used further on.
I will show you how to run the factor analysis model on the SBSS program. The first step, of course, is to choose dimension reduction factor. In the second step, we have to select the variables. So we selected all the variables except for the categorical ones. In the third step, we have to select descriptives, and an important thing of this part is to select the KMO and the parted test of sphericity, because with this process, because unlike the correlation matrix, this process doesn't make the correlation separately for each variable. It takes the variables in just one group, and it assesses whether the variables are correlated different and significant different than 0. For the fourth step, we have the extraction, and we have to choose between correlation matrix or covariance matrix. We chose correlation matrix because instead of covariance matrix, is less affected by the problem by the scale problem of variables. The fifth step is the rotation. As my colleagues showed you, we chose Varimax and an orthonormal rotation that allows us to make factors less independent from each other, and of course to help us to make a better interpretation of the variables. The step 6, it's about factor scores. We derive these factor scores and they are used for the subsequent analysis once we have made the dimension reduction of our factor analysis model. The 7th and last step, it's about other options because we have and we did the possibility of exclude cases, the ability of exclude small coefficients, and our criteria was to set the value at 0.4, so we consider only the factor when its absolute loading value was above this criteria, so 0.4. And that's how to do it. Thank you for your attention.
Any questions from friends? From what group? Question.
We distribute among our group of friends, and also we distribute it like open chat bubble beauty lover.
Can you give me more example of like how it's kind of like I guess situation? Like if we get the data and then what thing we can get out from the data and use it, I guess.
So at the top of my head, so here we have like 20 questions, right? So 20 questions. So each answer of each question would consider as one variable, and then we want to find the relationship between those, and then we want to group them. So at the end, as you see, we group them into 4 factors, which is the representative variable and the class like that. So I think the use of this in your ideas, maybe if you are doing some sort of research like this, and you want your question to be detailed, and but when you do analysis, you want the conclusion to be precise, right? So I think it's really not that way.
One more question. At the end, I saw that you conclude that there is 4 factors in total. So how did you come up that there are only 4 factors?
If you look in the rotated component matrix, you can like see we have just 7 components in the beginning because of the eigenvalues and of the total variance explained. And if you look at the output, you can like see that these 4 first components, they explain like most of the variables. So you can see the first component is able to explain like these types of questions, and then you go on and you can see like we had height, weight, frequently, like class per month, and the age. So these are just one-time factors, so they were not really explained by the other components. Because you need more values, so we just chose those 4 and used them to interpret.
Just going back to that, I think you said before that this table you can find out any value that is less than 0.4. Can you explain why it's 0.4?
Actually, it depends. Some people say it can be above 0.3 and 0.5, but in our case, we think that if we put point 4, it's more easy to explain our result. So if we want to, in this case, if we choose point 5, it will be there may be some variables missed, and if we choose point 3, there will be too many loadings here, and we will be hard to explain the result. So maybe in our case, we think point 4 is more appropriate.
Any more questions? I haven't got any question from time series.
I don't have the question.
So no more questions. Let me ask, if you click on next page, right? Can you say that factor 1 is more important than factor 2?
Just a summary of factor summary of the questions that are there together. So I wouldn't say that it's more important than the others. It's just a summary. Like this factor summarizes these questions, and subsequent analysis then is used with this factor. So then you can determine more often.
And maybe like if you take a look at factor 3, can you explain more in detail why is it represented what?
So we had a question like raw material quality on one side, and then the other questions were like price and accessibility, value, attractiveness of the branches. So how is the branch looking to you? Is it maintained well? Is it also part of service? How is the cleanliness of branches? So is the branch clean? It's all relating to service.
It's on the service of this stuff.
How is the situation look like and how the install?
So the question, for example, the business of the brand, so we just answer the question asked on actually title. Actually, we just answer so if you like the importance of the brand, the business of the brand that you need to
So that's how we think the quality of service. If I need to find one factor that's somehow tries to summarize that.
So just to summarize for your friends, right? So basically factor analysis is basically when you have many x. You know, like most of the time we have x, right? Something that you want to use to explain y, right? So basically it's about x, no y at all. Alright, but sometimes when you think that when you have many x, good thing no, right? For example, you might start with 7p, but at the end some p are highly related to each other. Alright, so what you realize that they have many variable x, and they combine to just at least just up to 7 of them. Alright, and basically the technique is just like you see that your friends actually talk about correlation. If variables are about the same thing, the correlation will be high. Sometimes it could be high in negative way, meaning that they talk about the same thing but in the opposite direction. Alright, so factor is in PCA that they use actually use a correlation actually to combine one that actually highly correlate. For example, if you take a look at component 1, you see that the one that have high value, that those are correlation, meaning that those questions are highly positively related to that component. Alright, and that's also how you explain that component is talking about what. Just like your friend says on the quality things actually have a high correlation on the question that talk about quality. Alright, so in IS sometimes you have many questions. You want to summarize to just some big component that explain easier in a way and also easier to handle. Just like I told you, like sometimes you start with 7p, but in that situation it may not to be just 3 group of p's, something like that, and then you can use that to help you answer your question research. Alright, but most of the time it's a technical thing, right? But at the end you have to know that what's the rules of this thing.
Alright guys, most difficult part has almost done, so let's go to the next easiest one, please. The time series analysis and the forecasting. Okay, so basically we have three parts here today. The background theory and the small research and something useful for your IS. Okay. So the first part is about the theory and backgrounds of this theory. Okay, so this time series has four components here. The long-term, cyclical, seasonal, and random. It's quite simple as you can see here. And those time series are to be used to forecast the future simply. By forecasting for the historical numbers or historical values, and then we can expect some numbers or values for the future. This is the trends, what we want to see from the graph or the values. Okay. Then the first one is about the long-term trend. Okay, you might see here that maybe this is very similar to the GDP growth for some countries, or maybe it might correlate to some stock prices or something for the small startup companies. So when we see about this long-term trend, which is we can mention for the more than 1 year period, which means long-term means more than 1 year. Okay, then so we can find some trends for incrementing or decrementing or some moderate flat value of those numbers. Then by seeing this graph, maybe we can expect it might increase or decrease or something. Then the next one is cyclical variation. It is more obvious trend we can see more than this one. So then this one is also the time period is long term. However, the shape of the graph is totally different. Cyclical variation has trend for up and down. But anyhow, we need to forecast the future. But anyway, this cyclical variation is most difficult part because maybe sometimes it's very similar to the random variation as well. Because in this cyclical variation, we can expect that it might have the peak of the value, but we are not sure when it comes. So maybe something similar to the stock price also, and also the currency or the condominium prices or something as well. Okay, the next one is seasonal variation. I think among those four items, maybe this is the easiest one to understand. For example, maybe every year some event happens. For example, Songkran for this year or Chinese New Year or something. And for those periods, of course, the air ticket fare is increasing, and after that, maybe it's somehow moderate, and then that continues as well for every year. Okay, this is the seasonal variation. So it happens every year or every cycle, but can expect in the time series. The last one is about the random variation. This is typically we can see that the economic or political situations are depending on the random variation, but maybe some good professors can find this trend of random variation. Then the random variation goes to cyclical or seasonal trend or something. Okay. Then the next part is about how we can find the trend. So in order to find the trend, we don't need to see the numbers or values one by one. Then we can do some calculation and then find the trend. The moving average, centered moving, and exponential smoothing. Okay. The moving average, maybe you might see this calculation, and then it's very simple that accumulating all the time series numbers and then divided by n is the period numbers. So this is the easiest one, and so the very good point is that, as I told you, that it's very easy. But on the other hand, we do not have any priority of each numbers. That's why in the time series, of course, we should prioritize the last number maybe for example the value of the last month is the most important compared to the 1 year before. So in that sense, this is easier, but we have more to improve. Okay. So for example, the moving average here is the 3 months average. And so in order to find the average here, so 3 months accumulated and divided into 3. So that's why it's starting from the March here. And then you can see the actual numbers, compared to the actual numbers, forecast numbers are more moderate because of the average values. Okay, then the next one is about centered moving averages. Okay, so this is more moderate, and we, as I told you, that the last one is more sensitive to the current numbers, or we didn't have the priority for each numbers. That's why we this is the improvement from the last one. That we have the average. The last number is here, the centered moving average. But in order to calculate that number, we have a black circle here and the gray circle here. So that's why in order to calculate one number, we gather 1, 2, 3, 4, 5 numbers until May. Then we can find the trends more precisely than the last one. However, by using this one, we can find the March trend number here. But in order to find this number, we need to wait until May. This is the maybe the point to improve. So in order to forecast the future, maybe this calculation is not quite enough or a quick response to the market. Okay, so the last one is about exponential smoothing. That's what we will use in our case for today. And exponential smoothing is the most improved one. That the calculation is quite difficult, so maybe Kumpesh will explain it later on detail. But anyway, we will calculate one number by using the prioritize the current, or not current, the previous number, which is the closest previous number. Then by using the exponential calculation, we use minimize the importance of the past numbers. So this is the system, the basic system of the exponential smoothing here.
Next, we will talk about the trend and seasonal effect, which including trend analysis, seasonal analysis, procedure for computing seasonal index, and the seasonalizing time series. Let's look on the trend analysis first. Since trend can be linear or non-linear, regression analysis can be used to measure the long-term trend, where the independent variable is time. If trend is approximately linear, we will use the quadratic model, this one, to find. But if it's non-linear, we will use polynomial model like this one to find it. Then move to the seasonal analysis. Seasonal variation can be within a year or within shorter interval, as explained in time series component S. And seasonal index must be computed in order to measure the seasonal effect of how much each season differs from one another. And also, there is one condition about seasonal analysis. Time series must be long enough to observe the variable over several seasons. Now let's move on to the procedure for computing seasonal index. First step, we remove the effect of seasonal and random variation by computing a simple regression line using below this formula. Then we compute the ratio for each time period, and this ratio will remove most of the trend variation. We use it by using the number we found on the regression model, and then we check if the average of the this one we put it wrong. Then we compute the average of the ratio in step 2 for each type of season. Then this step will remove most of the random variation, and also then we check if the average in this step 3, is 1 is equal to 1 or not. If not, then we have to adjust it to be equal to 1. Next is about the seasonalizing time series. This seasonalizing is a process to eliminate the seasonal variation in a time series, and the result from this process is called seasonally adjusted time series. By doing this, it will be easier to compare the time series across seasons. By removing seasonality, the real increase or decrease will become more realistic. Consequently, it will be easier to examine the factor caused the change. The process of deseasonalizing a time series can be done by dividing the time series by the seasonal index. Next, it is about the forecasting. There are like two main things that we have to measure the forecast accuracy. There is various type of forecasting variable to be used, but appropriate one must be chosen based on the type of component that make up the time series in order to achieve the greatest forecast accuracy. Two most commonly used is mean absolute deviation or MAD and sum of square for forecast error or SSE. Let's look on the forecasting model first. Forecasting model, we have three things. Forecasting model with exponential smoothing, forecasting model with seasonal index, and auto-regressive model. For forecasting with exponential smoothing, if the trend is very vague or there is no trend at all, and there is also no sign of seasonal variation, exponential smoothing can be an effective forecasting model. This one. If there is no cyclical or seasonal variation in the time series, the accuracy from the forecast of the next time period can be expected. Suppose that t is equal to most recent time period and st is equal to the value from compute the exponential smoothing. This value is the forecast value at time t plus 1. That is that equation. And 2 or 3 or more periods in the future can also be computed by this equation. Next, if the trend shows sign of seasonal variation or any trend, we can use seasonal index. The regression equation for forecasting used is below is this formula. And the last one is the auto-regressive model. Its autocorrelation is the error that are not independent of one another. The strong autocorrelation shows that the model has been misspecified. In other words, the result is not accurate unless the regression model is implied. However, autocorrelation also shows the opportunity to develop another forecasting technique, such as autoregressive model, which can be an appropriate technique and the most effective one if there is no obvious trend or seasonality, but correlation between consecutive residue is believed to be there.
Maybe it's more research that we about by using this time series. First, we think that okay. First, we assume that we are the hotel operation in the Phuket, and we want to explore the opportunity about the market that can grow or not, and we want to manage the vacancy in among the year that they might be have the volatile the occupancy will be not at the same level if we have no of the data to manage. So we conduct the research by retrieving the data from Ministry of Tourism and Sport. That they collect the data from the tourists that have going to from the disease of the tourists that made in the Phuket for the last 5 years. And we separate it by month and month. So we have the 60 period from January 2014 to the December 2018. So okay, we try to this is the data. So we use the data try to change it to 3-period moving average and 6-period moving average, and we have to compare it, and we use summary in the last page. So it is the basic what we call first one is we use the 3 mount of the before month, and we got this data to compare the April, and then the next is the 6 moving average. We got this, and this means we use this data to forecast for the next classifications. Okay, and we make it in the data to show that the actual trend, you will see that the quarterly moving average is have a very low gap more than the same.
Do you see that the orange one and the purple one looks smoother? Right? That's why it's called smoothing. Becomes smoother. Right? That's why it's called smoothing. Okay.
And then we try to do with another method is center moving average. So we use the 6 period of time. And then this is from the first 6 period, and this number from the another 6 period, and then we make the average, and we call it before. And this data we use to forecast the August, because we already used the 7-month period to calculate, and the data will come to forecast to the next period. Then you will see that is it's making a gap more than just 6 period, because it's use more of the data, but our data you will see in the blue line that it is very volatile due to the season of the year. Right? So it means that when you use more data to calculate it, it's increasing the error in your forecast. The next is the exponential smoothing. So this is the same that we split the number into 2 of the smoothing constant. The first constant is 0.2 and the second constant is 0.7. When you use the low smoothing constant, it means that you want the forecast to the trend, but if you increasing of the smoothing constant, it means that you increasing the sensitivity of the forecasting to detect the shape of the actual when it's changed, when it's occur, when the changes occur. And then we will summarize in the forecasting. So we use this the graph. You will see that smoothing constant in the low level is the orange line, right? The orange line is more gap, but the gray line is smoother than the orange line. And then is seasonal analysis. So we have to find the trend lines with from the Excel solver, so we get the number of the V0 intercept and the V1, and we make the trend line. But we found in the solver that the number of the beta one, the p-value is very high, so around the 18%. So that is might be the trend that we make it not significant to use for predict or forecast in the trend. And then we didn't do in the same level. We already talked before to be seasonal line and compute the seasonal index first. And then finally we got the seasonal index to make it so we got the seasonal index here, and we use this to forecast in the next slides. So you will see that we got the orange one, that is the trend line that we got from the Excel software. But the real one is that we didn't show the seasonal in here, but we will show it next time. It's in for forecasting. Okay. Then after we have the 60 period before we use analyzing the model, we use that model to forecast the next consecutive 7 periods in the year 2019, which already have the actual data of it. And the first one is that the moving average. You will see that when we calculate the MAD, as shown in the graph before, that 3 period moving average is more smoother, and that is shown right here. MAD is significantly lower than the 6 period. Then next is forecasting. We compare the 6 moving average from before, and we use 6 period center moving average. So that means we increasing the data from using to forecast. And as we see in the graph before, the MAD and SCE increasing because it's not smoother than it's rough than using the experience. And then the next one is exponential smoothing, whereas exponential smoothing. The number of low-wing smoothing constant will have the MAD larger than the higher smoothing constant, because of the higher smoothing constant have more sensitivity to the data than lower smoothing constant. And then we got this after we use the seasonal index analysis. This is the best of the model that we use, because EMA is quite low. It's quite 1 of 10 compared to the other model. Because that the seasonal is that like we have to forecast not only the number, but we forecast the trend in the next period by using the trend from the data that we received before. And then after that, you will see that the best of the model that we should use for forecast the number of the tourists who get is by using seasonal adjusting. So the possible topic that you can use this method to doing the research is that anything about that you want to forecast the trend, such number the delivery, number of customer that will intend to buy the house, number of the tourism, the number of the packaging, number of the food, anything that you might want to forecast, and the data is extrapolate the data that you get, so that you might to find the trend of the transient and use some of the model to forecast this.
Any questions from friends?
In the slide, in the very little slide, you already mentioned that approximately you said there were 2 formula to use for the relation. If it were linear, you would choose the linear programming and the other. So when you said approximately, does it mean that just like that you just draw a line and find the
You can use the regression linear model to find if the data one is significant, this one can imply that this data is the linear function. But if it's not, maybe you have to find like a seasonal index with like the research that you have.
question or any more question?
The first step line is the process that we have to find the trend line first. And then the trend line, first the trend line is show that, and we found that the beta one is not significant. So we used to find the seasonal index. We thought the seasonal index that the volatility has a pattern. It's not a finish line, it's just the start line.
So for this report, it means that it can only form the historical data, right? So if there is any new growth engine or anything that can drive the trend to be increased or decreased, how can we apply this to make the prediction to be correct?
I think if in that case you should use the exponential smoothing, as we say that increasing the smoothing constant will make your forecast model to more sensitivity to the sum of the condition that has been inserted into the relation or function of the model that you want to predict it. So if you want everything to strict to the trend line, you can lower the smoothing constant. But if you think that there's something that shape it permanently change or is highly changed in some of the period that have a long period for the prediction, you must to increase the sensitivity of the prediction of the smoothing constant to make a prediction.
So for seasonal analysis, when you remove in your data, I'm actually interested in this set of data. So when you remove the seasonality, you found the period. So
So, your question is when we remove seasonality, it becomes more immediate linear, right? Actually, the linear, right, that you see is the regression model here. We yeah, this one, this regression model, which is the starting point from here to find seasonal index. We use the regression model to find the
Regression model find the trend line, and then we calculate the seasonal index, and then we deseasonalize again to find that if we have the trend in the chain of the seasonal, I mean not only chain by the season, right? But in the long term they have the growth. It's gradually growth in this, right? You will see it.
okay,
So we deseasonalize because we want to see the major trend, not only the seasonal trend.
So interpreting that picture, meaning that the growth of the tourism here is steadily growing, right? Because removing the seasonality is going up a little. Right?
Yeah, we can imply that from the graph.
the gray one. The gray one is the deseasonalized graph.
Oh.
And you can see it's continuous increase.
Great.
The orange one is the regression model, while the gray one is deseasonalized one.
So, for example, if I want to know if any specific event causing the drop in tourism or not, I will just find the peak that maybe like go above the orange line or below a lot.
I'm not quite sure. We can summarize that or not. Maybe if we found that, we might have to find another information to support it. Also.
Any more questions?
Yes. you will calculate, use the another model to support the forecast. Also, I don't think that we use only the moving average to forecast something right now. But yeah, I don't quite sure that there is some other company that still use this. I'm not sure. I'm really sorry, I don't know.
You're from what?
Classification.
Classification. Do you have any comment question from answering? Oh. Okay.
Any question? No? Thank you.
Go back to the very beginning.
Beginning on the theory.
Yeah. Can you tell me what's the difference between cyclical and seasonal?
Cyclical is not happening in year, but seasonal is in this observation period. We can tell that they have a pattern in the observation period. Maybe not maybe it's not only a year.
How about if we talk about the sales at, like, let's say Big C, right? Let's say we collect data in like every week, every days, right? Like Monday, Tuesday, Wednesday, right? Within each week there is a cycle also, right? Because sometimes people go shopping mall during the weekend, right? And then within a month, it's kind of the same, right? But among between the month, each month, some month, for example, in April, during the end of the years, we have which one is seasonal, which one is cyclical?
So I think the week is seasonal because they had got a pattern in the observation period that we test do the research, right? But in the month, maybe it's the cyclical.
So it depends. So basically, what I'm saying is that you know, like in every data that has a small cycle, a larger cycle. Cyclical is basically talk about a very large cycle. Depends on what you look at. For example, when you think about economic cycle, for example, every 10 or 20 years, I don't know, there is some kind of like high going up and going down, this kind of things. That we would call that a cyclical, right? But in terms of planning, you have to think like, what is your main focus? If you plan about like annually, then you want to summarize data in form of like every month, so that you can make a plan, right? But if you talk about the management that actually deal with how many people should be at station on Monday, Tuesday, then you have to come down in more focus on like a weekday, those kind of things. See what I mean, right? So cyclical and seasonal, they kind of same thing, but seasonal is in more detail, smaller cycle. Cyclical is a larger cycle, right? The trend is actually just a big trend, a big one, right? So basically you will see that when you deal with time series data, it's about you observe something that's changing over time. But now there are many things that affect them. It's easier to look at a big picture first. That's a long-term trend. Right? That's like a phrase asked, right? Why are we looking at the trend? Why are we not looking at the seasonal? Because it's easier to look at a big picture first, extract the trend first, and then come down to a smaller cycle. Could be a cyclical, could be a seasonal, and then add those up. Right? For example, can you go some of the case and have a seasonal index, right? Can you talk about February and seasonal index of 1.2674? What would that be?
It means that in February they have the number of guests that hotel more than the average of the year in about 26%.
So that's what it means, right? These are like 100%. I mean that is at about the main trend. Alright? If seasonal index is above 1, it means that month is going to be higher than an average by that many times. Right? If it's below 1, it means that that month is actually below the average trend that many. What month is the busiest month?
The January.
January, February, and December. Right? Would that make sense for Phuket? Right? Which one is the worst one?
Which one is July, August?
Which one would you want to make like campaign so that you can attract more tourists?
July, August.
July, August. You see the point there. So if you do something like this, it's easier to analyze, to make a plan, right? Also, when you compare to more advanced, that you say that it's more accurate. Keep in mind, more advanced models use more in the level of the capability to interpret. Right? In this one, it's easier to say which one is has more value or low value. But when you use some more complex, you will not have something like this. I would say that. Alright, so it's at the end you have to think: do you want the accurate one or the one that have more meaningful in order for help to check and help to plan those things. Alright, but at the first you have to know that the data that we have is actually this is time series. Because time series talk about one thing. Like this right now is customer, is tourist. But time changing, the value is changing. Something like that. Alright? Okay? Next one. Mastery.
Okay, good evening everyone. Today our group will present about clustering analysis. Our agenda today will be the background of the technique, including about the explanation of the techniques, including the main objective, how to apply this technique to small research, and how to use the data and interpret the result in the real world or in the work situation. Okay. Then what is cluster analysis? Cluster analysis is a class of technique that are used to classify objects or cases into relative groups. It's called cluster. The cluster are different from the object in other group. And in cluster analysis, there is no prior information about the group or cluster membership from any of the objects. Cluster analysis will take a set of people or whatever that have been measured on a range of variables and put them into a group based on how similar they are to each other in terms of those variables. The objective of cluster analysis is to identify groups or clusters of participants that belong together. But it works by using the variable measured as coordinates in space. Each participant represents one point in that space, and then each measure the distance of each point from each of the other points. Points that are called together are clusters. But in the first step, each point is cluster which is nearest neighbor. In the next step, neighboring pairs of points are clustered together to form a bigger cluster, and so on. At the final stage of the analysis, all the points are clustered together into one giant cluster. The type of cluster analysis. Cluster analysis have various techniques but we will explain the more two popular methods. One is hierarchical cluster analysis, and the second is non-hierarchical cluster analysis or we can call K-means cluster analysis that we will use in the methods of in the small research. The first one is hierarchical cluster analysis. This is the most popular method to classify objects or case to find a relationship between the variables. It also known as nesting clustering, as it's also cluster to exist within bigger cluster to form a tree. This technique have to use, before use, they have to list the condition below. First one is the number of cases should be less than 200, and also the number of variables should not match as well. Second, you don't need to know the number of the group before you use the data. And third one is no need to know what is variable or case in each subset. Okay, then how hierarchical clustering works. Step one, we start by treating each observation as a separate cluster. And step two is repeatedly execute the following two steps. One is identify the two clusters that are closest together. Second, we will merge the two most similar clusters. This continues until all the clusters are merged together. And the third step is the main output of this technique or hierarchical clustering technique is a dendrogram. This will be in this graph. It's called the dendrogram that will show how relative of the data that are close or similar together. Okay, then we will talk about the non-hierarchical cluster analysis or K-means method that we will use in the small research.
Okay, so this one is, I'm going to explain about the K-means method. As you can see, for the K-means method, the sample that we use mostly is to be more than the large number sample, or is n, the sample is more than 1,000. And also for this method, you have to set up the hypothesis of the number of the cluster first. In this number, I'm gonna call it K. Call it K. And as you can see, this is a set of data. I'm plotting into the line, and I'm going to explain finally how it's separated into these three groups. Okay, so the step of the K-means method is that first thing. As I told you, we are going to set up the hypothesis, K hypothesis, or the group of the cluster that we want to separate. In this case, I'm going to separate it into three. Next, later I'm going to explain again why it has to be three, or what is the suitable number when you using your data. After you set up the K equal to 3, you're gonna see that the system gonna select the three initial point, it is the big blue, big green, and big orange. And then second step is that they are going to measure the distance between each point. So, and the group will be grouping with the one with the nearest initial data point. With this initial data point, you will see that the cluster gonna be grouping into this like two blue, two green, and the other is orange. As you can see, with the thing like this, they are going to measure the mean of the distance between each group. If the mean is equal, that means it's gonna end the grouping method like that. But as you can see, with the data set like this, this one is more makes sense compared to this, right? So how we are going to identify the quality of the cluster that they grouping. So in K-means cluster analysis, they are going to use the variations of the group to tell whether the quality of the cluster is good enough or not. As you can see, we did the three trials. The first trial is that they separate into this kind of group, and this one is the second one, and the third one is like like this. And then when we calculate the variance, we will see that the second cluster that we try all the variant is most equal, like all equal. That tell us the second grouping is better. And last time that I told you what is the K value that we should set up. As you, in this one we are going to use the variation number to tell us again. As you can see from the previous slide that with the yeah. Okay. So with the different K number, it's gonna give the different variations, and we plot that result onto the graph. In this one, if we set up K equal to 2, it's gonna give us the variation at this point. With the 3, it's gonna give us a bit higher. And then after the K equal to 3, the variation is going to be slightly changed compared to the previous one. So the suitable K value is going to be the point between the one that gives the low variance and the slightly different variance. And also K-mean method can also use with any kind of data. The one that I just explained is by using the data plot on the line. But if we give the data that given to us is the plot data, we can also using the K-mean method by finding the distance by using the Pythagorean formula to find the distance, and then book with the highest one, nearest one. And also, if we get the data like in the table like this, we have to transfer the data into the graph like this, and then find the distance with the Pythagorean formula again. Next one is about the difference between the K-mean and hierarchical method. As I told you before, that K-mean is that we trying to group the data that we have into the group of the cluster or number of the group that we set up. But for hierarchical is that if we get the data, the system gonna grouping the cluster with the most similar one. And also the sample size as well. The small sample size is going to use the hierarchical method, and the larger sample size going to use the K-mean method. And for K-mean method, the data that you use you have to standardize the data first. And also, last one is for K-mean method, for K-mean method, using finding the distance between the data point. Last one is the application of cluster analysis. Cluster analysis can be applied to like multiple fields. You can select the sample, select the data by, say, if the doctor collect the symptom of the patients. After they get the symptoms, the doctor can grouping the patient and give the right treatment to the same group of patients. And in marketing field as well, if you get the data of customer behaviors and you want to launch some marketing campaigns, you will think of the campaign with the right customer behaviors. Also, recommendation of the engine when you want to buy the car as well. You select the select, like, select the customer expectation, what kind of engine that they want and what kind of plan that the customer want, and give the right campaign to them. Next one, we are going to explain how to launch the data.
Okay, for the study topics, we chose the data about cell phone user behavior. And basically, one of the key challenges for cell phone companies or for the service operators is that they need to maintain their customers because it's a very low switching cost to their competitors. So we have chosen to look at the prediction of the customer's propensity of leaving. And our main objective is to classify the group of users according to their behavior. So our methodology, we're going to use the K-mean clustering. So our data actually comprises of 250 samples of cell phone users collected by the cell phone company. And the information consists of 5 different variables. So it's average monthly minutes, average monthly bills, percent use of business, years used in service, and household income. Since the objective is to classify the sample into groups, so we chose K-mean. And to check the condition, the number of sample needs to be more than 200, and also the variables have to be quantitative variables, so these meet the conditions. So step one, what we did was that we used the program to do K-mean, where K equals 3 with the 5 variables. And then step 2, we will use one-way ANOVA F-test to test if the means are equal. So for the results, you can see that we're looking at the final cluster centers with the SAT score. So what it means is that if it's positive, then it's above average, negative is below average. And you can see that like for cluster 1, all the values are positive. In cluster 2, all the values are negative, and in cluster 3, it's a mixed value. So we can conclude from this table that actually the SAT score in cluster 1 is the highest, so it has potentially be the best group of cluster. And then the second one has the lowest in the 4 top variables, the lowest SAT score, so it's potentially to be the worst, and then the third one is probably going to be in the middle. To reinforce that, we also have to look at the distances between final clusters to actually ensure that we're talking about the separation of the group is actually far apart. So you can see that the distance between cluster 1 and 2 is the most at 2.924. Then it's also important because we're looking at a group of customers, so it's important to see how many cases actually fit into each cluster so we can actually focus our marketing or resources to the right group. So you can see that we've identified that the second cluster actually has the worst SAT score, and it actually has most cases, which is 127 cases from 250, which makes more than 50%.
Okay, so next we will do further comparing cluster with ANOVA F-test. So we can see the p-value of average monthly minutes. The first row is 0.006, which is less than alpha of 0.05. So we will reject null hypothesis. So this means that variance among the clusters are not equal at the significant level of 5%, and the rest p-value is higher than 0.05. So this means that variance among clusters are equal at significant level of 5%. So from this result, we will know that we need to use Welch test for the first row average monthly minutes, and the rest we can use one-way ANOVA F-test. And for conclusion, as P5 already mentioned, that we have three cluster of the customer. So in summary, we can say that cluster 1 is the high potential group,
And cluster 2 is the low potential group, and cluster 3 is the in the middle moderate potential group. And what the company should do is that for the cluster 1, the company should maintain this group and try to promote some promotion and keep them to be the customer. And for the cluster 3 is somewhat in between, so they can maintain and review offers and might need to have more of a low cost offer. And for cluster 2 is the low potential group, so they can investigate and address the pain points. So that's it. Thank you.
Any question from friends?
I have questions on about the K value because I see when you have teach about the theory there is K to 3 and in research also K to 3. So is it a theory that it should be 3 or we can define the line graph and see the key point?
Okay. Actually, how to say it like this. We just assume the number at first. But if you want to know which one is better, sorry I deleted the slide out, but actually with the, if you set up k equal to 2, the variance is gonna be, the variance is gonna be not the same as this. If you can see, we set up the variance is equal to 3. So the variance of the 3 group is quite the same in this one. But if you set up the k equal to 2, the variance is gonna be different. It's gonna, so if you set k equal to 2, it's gonna be one big blue and the other small green. And if you set up the variance equal to 4, it's gonna be the other variance that give like one big blue and the other small green. And if you plot into the graph, it's gonna give you like this. If the point that's suitable, the most suitable is that the one that is not give you the big change, and also the point after is the one that slightly change. Am I explaining it clear?
So the variance is derived from your data that you have correct, right? The variance from the cluster that you have
Yes.
in previous slide.
The variance from the data that you get. It's like you're gonna get a group of data, and then the data is gonna be grouping into the group that you assign it for. You want to assign it to be 2 group, assign it to be 3 group, or assign it to be 4 group. With the number that you want to, the number of the group that you want to assign is gonna give you the different variants.
Any more question? But I think it's almost like R squared, you know, like if you go back to understand thing, right? Like example, if you have no cluster, right? What you're comparing is like the middle point is right here. The variance is distant away from the mean square on average. Right? So when you increase cluster, you see this grid now is group compared to this line. This group compared to this line. So this can become smaller. The key is that when you increase cluster, at the edge is decrease variance within the group, those kind of things. So the thing is that if you increase, if you move on the next page, right? So we expect that when you increase the cluster, it's supposed to be better, right? So but the key is that you pick the one that actually have a big jump. Whenever it doesn't have a big improvement to start. Like from here to here, no, it's very small. From here to here, not so much. So this is how. Any more question? Yes.
How do you differentiate like between factorial analysis and cluster analysis?
The question is what's the difference between factor analysis and cluster analysis?
Factor analysis answer.
Factor analysis is about the reduce the variable, but for this one I think it's reduce the number of variable for factor.
So it's more like segmentation as well, on both bases
The
of
factor is trying to reduce the factor, but this one is trying to the
Sample. Group sample.
Cluster combining the observation, but factor analysis is basically combining the variables. For example, you ask 20 questions from 1,000 people, right? Factor analysis is combining 20 variables into groups of variables. But clustering is basically combining from those 1,000 people, how many similar observations are there. So these two are very similar but in different views. Any more questions? Okay. So I think you see that the key here right now is that for clustering, the key is that you have any observation, right? And then you want to see from this many observation, how many groups that similar to each other are there. Right? It's more like you segmentation your customer business. Most of the time in marketing you have many customer, you want to segment them for people that are similar in the same groups. So that you can customize campaign, promotion, product for them, those kind of things. Right? Something like that. Can you go to see your variable that you use in your small the key element for doing a good clustering is that first you have to think, why do you do clustering? Right? For example, right now, if you say that you want to segment them so that you can customize a certain promotion, then you have to think of what variable do you need. In this one, you see, now you have 5 of them, right? Each one should represent different things. Right? For example, the first one is like the volume of how many minutes they use. Alright, second one is what? How much they pay. It's similar to minute, but it's different dimension, right? Different thing, right? And then the third one is what? So meaning that it is high percent in what? They use for work, is that right? Right? Use for work or use for personal, is that right? Right? So meaning that if they have high percent of use for offices, meaning that maybe that customer might be more like not personal use, but it's actually for use for business kind of thing. Right? And years of using of serving between how long they stay with us, right? And the last one is actually how long, right? But you see that when you break into 3 of them, I think that the third dimension is actually kind of right? So if you jump to yourself, you have to request it, right? You see that at the end it becomes just like high user and low user and medium user. When this happens, I don't think any more variables that actually the machine. Because maybe you might want to have like something like a mix of like high user but